So for 26.1, first of all, make sure that you have your book turned to page 401 and that you have your graphing calculator in front of you because we are going to need both those things for this lesson. So we've studied inverse functions before. We've also talked about logarithmic and exponentials being inverses. So just a brief review here of what we know about inverses. First of all, up here, this is the definition of inverse. So this right here is the definition of inverse. That is, if two functions are inverses, when you do their compositions, f of g of x and g of f of x, it simplifies to x, which should make sense because if they're inverses, they undo each other, which means you get back exactly what you put in, which is x. So today we're going to look at square root functions in the capacity of inverses. So in example A in your book, it has this already typed out for you, but it asks you to graph the inverse of f of x equals x to the 1/2. And all the pictures that you see up here, some of them I had to make small to fit them, but it's in your book. So you can look at your book. You don't have to look necessarily on the screen here. So remember that x to the 1/2 power is the same thing as the square root of x. So this is the same thing as this guy. It asks us to graph that, give its domain and range of that and the inverse. So this is just reviewing how we would graph an inverse and how we would find it. So graphing f of x, that's just the parent function. So they listed it like this. We usually list it, in ordered pair form. But this was our parent pattern, and we usually just do the 3 points, but they have an extra one there at 9, 3. So this is our parent function, hasn't changed any since we graphed them in lesson 25.1. Remember that inverses, one way to find them when you're finding them by graphing is to just take the ordered pairs and switch the x with the y. So that's what they've done here. Obviously 0, 0 and 1, 1 don't change, but the other two do. And so then they just plotted those 4 points. So you can see that here in the green. They plotted 0, 0, 1, 1, which are matching up, and then 2, 4, and then 3, 9. So this is the inverse, which they got when they did step 3 and connected the dots. It says, consider the x and y values of the graphs to determine the domain and range. So domain and range of the original we already did in lesson 25.1. So its domain and range are both from 0, including 0, to infinity. When we look at the inverse function, we look at the x's. X's also seem to be starting at 0 and getting bigger because they're going to the right. Y's start at 0 and get bigger, so those also are going to be 0 to infinity. So it gives you the solution here. They wrote them in inequality notation. So the domain of both is x greater than or equal to 0. In interval notation, that would look like this guy. And then the range is the same. It'd be y or f of x or g of x or whatever the case may be. Again, if we were writing it in interval notation, it would look like this. So remember that when we are graphing points, we get an inverse by simply switching the x, y coordinates and then plotting the points. Now in example B, it reminds us the steps to algebraically find an inverse, meaning we actually have to do some work and some steps. So it says for f of x equals x to the 1/2, so again that's the same thing as f of x equals square root of x. We want to find f inverse algebraically, then give the domain and range of f inverse. So first thing we always do is let y represent f of x. So when I write the steps out here, I usually put replace function notation with y. So that's what we did here. We took out the f of x, we put in the y instead. Again, if you prefer to write the square root instead of the 1/2, you're more than welcome to do that. It shouldn't matter. Next, we flip-flop x and y. So notice where there was a y, there's now an x. Where there was an x, now there's a y. And then step 3 is to solve for y. So to get y alone, we need to undo this 1/2 exponent, which is a square root. We undo square roots by squaring both sides. So those will undo each other. We have y alone on the left side. On the right side, we have x squared. Now, I'm going to make this step 4, and that is put in the inverse notation, f inverse of x. You have to put that back in at the end. So f inverse of x would be x squared, which makes sense because the inverse of a square root of x should be x squared. They're opposites. Now, it asked us to find the domain and range, so we should know what x squared looks like, so they didn't graph it to find the domain and range. We can, if you just know it, that's great. But the domain is all real numbers, so that we would write that -infinity to infinity. The range is y greater than or equal to 0, so 0 to infinity. The really important thing to notice here is that when we took the same function, f of x equals x to the 1/2, when we found the inverse by simply switching the x and y, and when we found the inverse algebraically, we got different domains. Here, we got domain as all real numbers, and when we plotted, we got domain is all real numbers greater than or equal to 0. So we're going to have to talk more about that because that's important, and we have to know which one is right. So we're going to practice a little more first, and then we're going to come back to that idea. But I just want to plant that in there to notice that we did, even though we started with the same function, get two different answers graphically from algebraically for our domain. So we're going to practice here and try these part A, graphing this guy just by switching x and y's with the inverse. So my original f of x equals x minus 3 to the 1/2. So again, that's the same thing as the square root of x minus 3. So it says using the values x equals 3, 4, and 7. So that means we can make a table, 3, 4, 7. When x is 3, 3 minus 3 is 0, square root of that is 0. When x is 4, 4 minus 3 is 1, and the square root of 1 is 1. When x is 7, 7 minus 3 is 4, square root of 4 is 2. So we can plot these 3 points, 3, 0, 4, 1, and 7, 2, and that's going to give us our function. Now, we should have been able to graph that without making a chart, but we're following the directions here because all this is a horizontal shift right 3 of our parent graph. So that would give us the answer as well. The reason why they had us do it this way is so that we have the ordered pairs already listed for when we go to do the inverse. So graph its inverse on the same axes. So I'll use a different color here. So f inverse, we switch the x and the y. So we should have the point 0, 3, 1, 4, and 2, 7. So I plot those. 0, 3, 1, 4, and 2, 7. Now in part B, they want us to do the same thing, only algebraically. So we're starting, and I'm going to do that here out in the margin. You can use your margin too if you need more space than what they've given you. So our original is f of x equals x minus 3 to the 1/2. Again, this is a radical equation. We're following these same steps that we just did up here in the one we walked through. So first thing I'm going to do is put a y in instead of the f of x. Next, I am going to switch the x with the y. So x equals y minus 3 to the 1/2. Then I need to solve for y, get y alone. So I need to undo this 1/2 power, which the opposite of a 1/2 power is the power of 2. So I'm squaring both sides because I'm undoing a square root. So that gives me x squared equals, these cancel, so I have y minus 3. Y's not alone yet. I'm not done solving for y. I now need to add 3. So I get y equals x squared plus 3. So final answer, f inverse of x equals x squared plus 3. So down here, it talks in your book about what I talked about earlier. When we found the inverse using 2 different methods, we resulted with a different domain. The explanation for this is subtle, but very, very important. And that is, and I want you to circle this, highlight this, star this, somehow indicate that this is really important. The domain of the inverse function should be restricted to match the range of the original. So here, x squared plus 3, I can graph that without doing any work. It's a vertical shift up 3 of the parent parabola. Its domain is all real numbers. However, when I did the inverse by picking points, the domain of this guy is all real numbers greater than or equal to 0. You have to choose the one that matches the range of the original. So in red was my original function. The range of that, the y values start at 0 and get bigger. So that means the domain of my f inverse function should match the range of this, which is 0 to infinity. So when you find it algebraically, you have to go back and think. You have to match it. Because remember, all inverses are switching the domain and range. So all you're doing is taking the domain and range of your original, switching that, and that should be the domain and range of the inverse. So I would actually very highly suggest doing domain and range that way when we're talking about an inverse. So my suggestions here are to find domain and range of original and switch them. So make the range the domain, make the domain the range to find the domain and range for f inverse. Because that way you won't have to worry about the restricted domain. It will already be restricted to exactly what you want. All right, next part of the lesson, we are going to be talking about regression. So this is why I said you needed your graphing calculator out in front of you. So we've already done linear regression and quadratic regression. So now we're going to look at some square root functions and how we could do that on our calculator. So in your book here, on, let's see, what page is this on? Page 403. And for some reason, my table is written vertically where yours is written horizontally, but it's the same data. It says a physics class conducted an experiment comparing the period of a pendulum to the length of the pendulum. The results of the experiment are given in the table below. So here's the table, the experiment. This was the length of the pendulum. This is the period, the time. So it wants us to make a scatter plot of the data on the coordinate grid. You can cross out number 4 because there's no reason to actually plot that by hand when we're going to be doing the work on the calculator. So what you do want to do in that margin is make sure that you know the steps for getting data in your calculator and making a scatter plot. So on your graphing calculator here, we're going to look at mine and we're going to go through the steps. Make sure you're following along with this because there's a big difference between watching me do it and doing it yourself. All right, so on your graphing calculator, the first thing we need to do in order to make a scatter plot is to turn your plots on. So press second, and then stat plot, the y equals, and we're going to turn plot 1 on. So press enter on top, turn it on. Make sure that these settings are how we want them. The scatter plot is the first type. We're going to use list 1 and list 2. The first mark doesn't matter the color if you have a color version. Remember that you can also turn plots on and off in your y equals screen by simply scrolling up and press enter on top of them. So if you know that you have the right settings, you can do it that way. I wanted to double check your settings. So in order to make a scatter plot, the first thing we need to do is to make our list. So press stat and press edit, choice 1. We are going to enter our data in list 1 and list 2 here. So from the data that you see in your table, we're going to type in the length as our list 1 and the time as our list 2. So I'm going to do that live with you to make sure I give you enough time. So just go ahead, press enter between each set, but we are going to enter all of that data in list 1 and list 2. I'm entering the time in list 2 because I'm done with list 1. When you finish entering the data, first of all, check that they match up. You should have the same number of data entries in both lists. Also double check them because remember your answers are going to be wrong if your lists, if you typed in, 16 instead of 14 or something like that. So double check them, 6, 10, 14, 18, 22, 26, 30, 34. On the Y list, 0.8, 1, 1.2, 1.35, 1.5, 1.6, 1.75, 1.85. So make sure that those are in there. Once you have the data in there, in order to get a good screen for the scatter plot, we go to zoom and then we choose choice 9, stat, because stat is where we went. Now, when you do zoom stat, it gives you an idea of a window to use. Usually we will have to manually adjust it because we want to be able to see our axes. So this goes from x equals 3.2 to 36.8. So I would probably change that from x equals 0 to x equals 37. Then I would probably have it count by 2s so that I could see the marks. Y-min, they have 0.6. We'll just make that 0 as well. It goes up to 2.2. I would probably make it go a little above that, so maybe 2.5. And then I can press graph again, and now I can actually see my axes along with my scatter plot. All right, so number 5 in the lesson then, once we have that, what parent function does the path of the data points resemble? So if we look at the shape, it's gradually going like this. It looks like an eyebrow, and that's our square root function. So that's what we're going to say here in number 5, that it resembles the parent function f of x equals radical x, or remember that that's the same thing as x to the 1/2. So both of those are correct answers. So what we're going to do next is regression, and on your book in page 404 it has the steps. So step 1 is what we already did with entering the data. So we've already done that because we chose not to graph it by hand because there was no reason to do that. So we're on step 2. To actually find the equation of best fit, we need to run regression. And this is very, very similar to what we did when we did linear regression and quadratic regression. So it tells you in your book that the next thing we need to do is press Stat, then move the cursor to highlight the Calc menu, and then we're going to choose choice A, which says Power Regression. So again, the steps are here and it shows you, but I'm going to show you on here. So we're going to press Stat, we're going to scroll to Calc, and then we're going to choose choice A. It's actually faster to go up usually than down, but you can go either way. So choose choice A, press Enter. Now, if you have a newer calculator, you're going to see this screen. So it's kind of nice that the book has screenshots because they have the older version screenshot. So if you have the older version, hang on 1 second. I'm going to go over the newer version first. So you need to make sure that your lists match up. We put our X data in list 1 and our Y data in list 2. If your power regression doesn't say that, you need to change it. Remember that you name lists. Lists are in blue, so you have to press second first. So if I wanted to change this to L3, I would press second 3, and it would change it. Obviously, I really don't want to do that because I want list 1. So second 1 for list 1, list 2 for the Y list. You skip the frequency list, store regression equation. This is really important that you remember to do this. We need to automatically paste the regression equation that it gives us into our Y equals. So we've done these steps before. I'll write them out for you here in a second. But you're going to press vars, scroll right to Y vars, choose function, choice 1, and then choose 1 for Y1. This is going to automatically paste it. Then you can press Enter on top of calculate, and it's going to give you the equation. Now, if you have the older version of the calculator, you don't see that same screen when you chose power regression. You just see, it'll say power regression, and that's it. You need to tell it which lists to use, and you also need to tell it to store. So next to where on your home screen it says power regression, it may have a parenthesis, it may not. So if it does, great. If not, that's okay. You're going to type second 1 because that types L1. Then you're going to press your comma, which is right above the 7 key. Then you're going to press second 2 to type L2. Then you're going to press comma again. And then you're going to type in the Y1. So if you were waiting for me to write down the steps to type Y1 or Y2 or any of that, you press vars first. Then you scroll to the right to where it says Y vars. Then you choose choice 1, which is function, and then we choose choice 1 again, which chooses Y1 for us. So that will type Y1. So if you have the older calculator, you need to press this in before you press enter. If you pressed enter first, you're going to have to go back to step 2 and do it again because you have to have the pasted equation. Otherwise, your answers are going to be inaccurate. So, now that the calculator is displaying our answer, it tells us the format of the answer as well as the values of A and B. So this is saying that the format of our equation is this, because that means exponent button. And it's telling us that A is about 0.33048, so on and so forth, and B is about 0.487, so on and so forth. So when it wants us to write the equation, it says to round to 2 decimal places. Now, they did that for you here in the solution. So they're saying y equals 0.33x to the 0.49. So you can see that on the next part that says the solution. So a square root function, this is about 0.33 times radical x. That's a good fit for the data. It wants you to check by graphing this. You don't need to do that. You just need to press graph because we already pasted the equation in there. So because my equation is pasted, I can go ahead, I can double check that it's there, which it is, see it up there. And when I press graph, then it's going to actually graph the equation. And so what it asks next is this a good fit for the data? So obviously we would say yes. When we explain our reasoning, we can say that the points fit very closely. Now, one thing I guess I should go back and say, since it doesn't say here, I just want to point out why we're using the square root here and make sure you understand. This 0.49 is very close to 1/2. And remember that x to the 1/2 is the same as the square root of x. So I just wanted to clarify that real quick as to why we're saying that that's approximately a square root function. So we said yes, the points fit closely. As you can see, once the whole thing is graphed, it goes right through most of them there. 8 asks us to give the domain and range for our square root regression. Write your answers using inequalities. We don't do set notation and interval notation. So for the domain, when we look at our picture, and if you want to change your window so that you can see some of the negatives, just to make sure, we could change our window here, -5 as my min on both axes, and that should take care of it. So even though we know that there's nothing else, if you want to confirm that there's nothing else, this shows you. So shows us here that we do start at 0, and if we look at the table, second graph, you can see that at 0, 0 is defined. So that's where our domain and our range are both going to start. So our domain is from 0 to infinity, and so is our range. Now that's interval notation. Inequality notation, we write the sandwiches, or no, we don't have to this case. So x greater than or equal to 0 would be inequality notation here. Here for the range would be y greater than or equal to 0. So make sure you know how to do both because, on the embedded assessment, it usually will specify which format for you to use. Number 9, use the square root model to predict the period of a pendulum that is 40 inches long. Round your answer to 2 decimal places. So what they're doing here is they're giving us the length. So if we look back at our table that we used on 403, length is the x. That's in our list 1. So it's telling us that x is 40, and it wants us to use the square root model to find the period, which is time, rounded to 2 decimal places. So we can do that in our calculator. We go to the second trace menu and we choose choice 1, which is value. But the key is make sure your window is appropriate. I want to plug in x equals 40. I have to make sure that my window goes up to at least x equals 40, which right now it does not. So I'm going to change my x max and make it 42. And then press graph again. So now my window is going to be plenty big enough, which means I can simply go to second trace, move it over so you can see that part. So second trace, and then we see choice 1 is values, so press 1. Sorry, I have to move it up to do that. And then you just type in 40. So 40, enter, and then it's going to spit out an answer. You will not get the same answer if you do not paste the equation. That's why this step with the vars is so important. Your answer will generally be a little bit off. So here it said to round to 2 decimal places. In this case, rounding to 2 decimal places actually gives us 2.00. So and I wouldn't need you to put the decimal places. I'm just putting them to make sure that we realize that that is a rounded value. That's not exactly what came up, but it said to round to 2 decimal places. All right, then number 10, use the regression equation, the one that's already pasted for us, to find the length of a pendulum that has a period of 3 seconds. So the period is the y value. They're telling you y equals 3. So this one, we have to use second trace, choice 5. We have to do an intersection. So we need to press into our y equals screen, the y equals 3. So y equals 3, press graph. And of course we can't see it because my window isn't big enough, so we go down and make sure, whoa, if I change that to 3.5, well, 3 will be good enough probably, but I want it to be a little bigger, so we'll go to 3.5, and I graph it. Then I should be able to find the intersection point. Again, you have to do second trace intersect in order to find it. Now, I can see here, even though I can see my 3, I cannot see the intersection, which, like from the homework before, it was trying to prepare you. That means that my window isn't big enough. So I'm going to make my window like 60 and see if I can see it there. Still not even, so a little bit bigger. Let's go to 80. And hopefully I can see the intersection as I get a little bit closer. All right, it's almost there. I'm not totally sure that it's in there, so I'm just going to make it 86. I don't know. Again, this is exactly the process that you should be using when you're graphing your own things. The window is a trial and an error. Can you see it? If you can't, then what do you need more of? So now I go to second trace, choice 5, and the intersect. So I'm going to get the intersection close. Then it's asking, is what's in blue my first curve? Yes, that's my regression equation, so I press enter. Is y equals 3 my second curve? Sure is. So press enter. Then it's asking, do you want me to guess? Absolutely. Press enter a third time. And why is it doing that? Let's try again. Second trace, intersect, enter, enter, enter. I don't know why it's doing that, because I have done this before on my own and gotten the right answer. And of course I can't erase on a video. I'm not going to have time because I know it's really close to what we have to do as far as the period ending. So I'll figure out what it is and I'll let you know tomorrow, but the intersection point should be the book's answer says about 82.5. That's actually going to be a little bit off, I'm pretty sure, because they used a rounded answer. But somewhere in the 80s is our answer, and I'll look and figure out why that wasn't working and let you know tomorrow. Oops, I put it in the wrong place too. That's the answer to 10. We're not doing 11. We already talked about that. All right, that is it.